In the last section, you would have learned that there are 5 properties of parallelograms. In this section, we're going to learn how to look at those 5 properties and learn to use them to prove that a quadrilateral is a parallelogram. So, what are the 5 key properties of parallelograms? 2 pairs of opposite sides parallel, 2 pairs of opposite sides congruent, 2 pairs of opposite angles congruent. We also learned that the 2 consecutive interior angles are supplements and that the diagonals bisect each other. So if we look at these key properties and we could show that these are true, then we can use those to actually prove that something that we don't know is a parallelogram actually is a parallelogram. So all of these are basically like converses of the theorems from section 7.2. So here's a quadrilateral. If both pairs of opposite sides are congruent, then I can conclude that this quadrilateral is a parallelogram. Okay, here's another converse. If both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Here's another converse. This one's a little bit different than the properties that we looked at. This is the one that you probably are going to have to pay the most attention to as you're studying, because it's one of the theorems that's not a true converse of what we looked at before for the properties. This one says that you have to have 1 pair of opposite sides, both congruent and parallel. The idea is that we're only looking at one side, but that one side has both properties. It's congruent and parallel. And if we can show that, then of course, quadrilateral ABCD will be a parallelogram. And lastly, you've got the parallelogram diagonals converse. If the diagonals of a quadrilateral bisect each other, right? So this diagonal is being bisected, and also this diagonal is being bisected, then the shape ABCD, the quadrilateral, will be a parallelogram. And similarly to when we talked about diagonals being bisected before, we're saying that these are being cut in half. We're not saying the diagonals are the same length. So AC is not the same length as BD. We're just saying that this guy right here where they intersect is the midpoint. So we want to be able to prove at least one of these. In other words, we need to have practice doing some proofs where the thing we're trying to prove is that the shape is a parallelogram. So there are 5 ways to prove something is a parallelogram, right? We just looked at those 5 ways of proving something is a parallelogram. 4 of them are just the converse of the properties that we looked at. So let's take a look at this proof. Okay, so the first thing that we're going to do is put in the given. So the given was that AB was congruent to CD, and also that BC was congruent to DA. And in addition to marking the given in our proof, we also want to make sure it's marked on our picture, and it is, right? It's marked in our picture. So diagonal AC has already been drawn. And we'll notice that diagonal AC is giving us the ability to create 2 triangles. So I've got my 2 triangles. And now that I have these 2 triangles, the easiest thing that I could do is just show that these 2 triangles are congruent to each other. And that's actually pretty easy to do because AC is congruent to itself by the reflexive property. So that gives me 3 congruent sides. And that means that these 2 triangles, the green triangle and the yellow triangle, are now congruent by side, side, side. So these are congruent by side, side, side. And that means that angle 1 and angle 2 are congruent. So how do I know angle 1 and angle 2 are congruent? Remember, these two angles, angle 1 and angle 2, they're parts of congruent triangles, right? So congruent parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent, so CPCTC. So why did I want to show that angle 1 was congruent to angle 2? Well, if you look at my picture, I hope you can see that angle 1 and angle 2 are actually alternate interior angles, right? There's my two lines. And angle 1 and angle 2 are alternate interior angles. So I've just showed that angle 1 and angle 2 are alternate interior angles that are congruent, which means side BC is now parallel to side AC, AD, right? Because alternate interior angles congruent buy me parallel lines. So what do I have now? I've now shown that side BC and side AD are parallel. I already had side BC was congruent to AD. And one of the ways you can show something as a parallelogram is by showing that one pair of opposite sides is both parallel and congruent. So we're utilizing one of the 5 theorems that we had to show that a quadrilateral was a parallelogram. So now we want to look at these pictures and we want to be able to determine if these pictures satisfy one of the 5 ways to prove that a parallelogram. So we're looking for, do we have opposite angles congruent, or do we have opposite sides congruent, or do we have opposite sides parallel, or do we have diagonals bisecting each other? And then the last one we had was one set of opposite sides parallel and congruent. So are any of these 5 theorems happening in these pictures? Okay. Well, let's take a look at this one. You've got, this is 75 degrees and this is 105 degrees. So what I see is that these two angles are supplements, and that means that these two lines are parallel, right? These are same side supplementary angles. Same side supplementary angles. That's how I knew the lines were parallel. So now that they're parallel, they're also congruent, and therefore I get one set opposite sides parallel and congruent. That makes this guy a yes. Okay, what else do we have? Let's look at the next one. So we've got opposite angles congruent and opposite sides congruent. But remember, you needed to have 2 pairs of opposite angles and 2 pairs of opposite sides. So that makes number 2 a no. Let's look at number 3. Do we have one of the 5 theorems? Yes, we have diagonals bisecting each other. Let's look at number 4. Yes, we have 2 pairs of opposite sides congruent. Okay, let's look at number 5. We have parallel lines. How did I know I had parallel lines? Because they showed me that these alternate interior angles were congruent. Right? So that gives me parallel lines here and here, and I already had a pair of parallel lines here. So that one is a yes. And in the last one, since I know the total number of degrees in the parallelogram has to be 360, right, because it's a quadrilateral, that means that that last angle that isn't shown has to be 120. And once I know that I have 120, I've got 2 pairs of opposite angles congruent, and that makes this one a yes. So you'll be given pictures like these, and you are going to need to decide whether or not you have one of these properties happening, right? One of these theorems that shows how to prove something is a parallelogram so that you can decide yes or no. Okay, so you've got a quadrilateral and they gave you some of the angle measures. So let's draw it out first and solve for this last angle, angle Z, by knowing that the sum of all the angles will be 360. As soon as we find out that Z is equal to 138, we notice that we have opposite angles congruent, and therefore this is a parallelogram. In order for this to be a parallelogram, you need to have opposite sides congruent. So those two sides are congruent, those two sides are congruent, and that allows me to set up two equations and solve for x and y. In order for B to be a parallelogram, I need the diagonals to be bisecting each other. Therefore, these two segments are congruent, and I write my equation 4x minus 11 equals 2x plus 17 and solve. So try these ones on your own and pause the video and then check your answers in a minute. So when showing something as a parallelogram in the coordinate plane, the easiest way to do it is to show two pairs of opposite sides parallel. And remember, to show things are parallel, you just have to show the slopes are the same. So I can show that AD has the same slope as BC. Right? These two have the same slope. And you can use the slope formula, or you can just use your picture. And I want to show these guys have the same slope. So because I've shown the same slope, the sides are parallel, and because I've shown two pairs of opposite sides parallel, I've shown that ABCD is a parallelogram. So this is just a summary of the ways to prove a quadrilateral is a parallelogram. There were 5 ways, and you have a picture on the side. And you're going to want to commit these to memory, just like you did what are the 5 ways to prove triangles congruent, or what are the 5 ways to show lines are parallel.